There may be nothing stranger than this. We exist because matter and antimatter simply can't coexist. But why? Why does the universe exist? Why is there something instead of nothing? If you're searching for one of the deepest mysteries of existence, stay with us because this video is about to shake your mind. The universe exists because matter and antimatter, despite having similar properties in many ways, are fundamentally incompatible when they interact. A timeless and profound question has always occupied the minds of philosophers, scientists, and thinkers: why does the universe exist? In other words, why is there something rather than nothing? At first glance, the question seems simple, but upon closer examination, it turns out to be one of the most fundamental and most difficult questions humanity has ever faced. For centuries, philosophical and religious traditions have tried to answer this mystery, sometimes by invoking a creator beyond the universe, and sometimes through logical and metaphysical reasoning. In modern times, science has also stepped in, attempting to offer a scientific picture of the origin of existence through cosmology, particle physics, and quantum mechanics. The answer to why the universe exists may lie in the concept of asymmetry. Scientists have discovered that the universe came into being because, at its birth, there was a slight imbalance between matter and antimatter. The matter that makes up our world consists of particles like protons, neutrons, and electrons. Antimatter, on the other hand, consists of particles that are essentially the same but with one key difference: their electric charge is reversed. For example, while an electron carries a negative charge, its antimatter counterpart, the positron, carries a positive charge. That's why we say matter and antimatter are similar in many ways, but differ in terms of electric charge. When particles of matter and antimatter collide, they annihilate each other completely, releasing a tremendous amount of energy in the form of gamma radiation. This reaction shows that matter and antimatter are not friends. Fortunately, there is very little antimatter left in the universe today, otherwise, everything would have been destroyed in an instant. Still, this scarcity of antimatter remains one of the great mysteries of cosmology, because antimatter played a crucial role in the early universe, and it's unclear why it has nearly vanished. If you've stayed with us this far, know that we've just reached the most mysterious part of the story. If you want to understand why we are made from the remnants of a cosmic battle, don't miss the rest of this video. And if you enjoy content like this, subscribe now so we can explore the depths of existence together. According to Live Science, about 100 years ago, British physicist Paul Dirac predicted the existence of antimatter through his work in quantum mechanics. From the 1930s onward, experiments confirmed his prediction. Today, scientists can produce antimatter in laboratories using advanced machines like the Large Hadron Collider, although the amount is extremely small and very difficult to control. Pasquale D.I. Barry, professor of physics and astronomy at the University of Southampton in the UK, says that when Dirac predicted antimatter, he believed matter and antimatter should exist in equal amounts. That is, if there's a certain amount of matter in the universe, there should be the same amount of antimatter. But in reality, antimatter is extremely rare, while matter is abundant, so much so that all stars and galaxies are made of matter. This huge gap between theoretical expectations and observed reality is a major scientific puzzle. Some scientists once thought there might be antimatter galaxies or antimatter stars, but none have ever been found. A particle physicist at the University of Liverpool explains, "We think the universe began with roughly equal amounts of matter and antimatter after the Big Bang. But very quickly, matter dominated. For that to happen, there must have been a very small difference or asymmetry in how matter and antimatter behave, so that one could eventually overpower the other." According to Shears, it's still unclear why matter and antimatter behave slightly differently. Scientists don't know where this difference comes from, and there's no clear scientific explanation yet. Understanding this difference and why matter won out is the central mystery of matter-antimatter asymmetry that researchers are trying to solve. Dirac noted that the naming of matter and antimatter was arbitrary. We call the familiar particles matter and their opposites antimatter, but it could have been the other way around. If more antimatter had survived, it might have formed a universe of anti-atoms and anti-molecules. In the end, what remained was named matter, and the rest became antimatter. Physicists are using advanced experiments and observations such as particle accelerators, traces of antimatter decay in starlight and galaxies, and even gravitational waves to try to understand why there's such a vast difference between matter and antimatter in the universe. This difference is what ultimately allowed everything we see, stars, galaxies, Earth, and ourselves, to exist. D.I. Barry believes that in the earliest moments after the Big Bang, there were far more particles of both matter and antimatter than there are today. Most of them collided and were annihilated. What remained became the matter that eventually formed stars, planets, and life. Put simply, we are made from the leftovers of that initial cosmic battle. Sakharov proposed that matter and antimatter do not behave as perfect opposites. When exposed to certain fundamental forces, their behavior differs slightly. This tiny difference allowed a bit more matter to survive and build the universe we live in. In physics, this phenomenon is known as C and CP violation. Volkers explained that scientists understand the general principles behind why matter and antimatter behave differently, but the exact details are still unknown. In a universe shaped by an uneven battle between matter and antimatter, we humans, Earth, the stars are all made from the remnants of that primordial explosion. The universe exists because balance was broken, because matter endured. Just a little more, but we still don't know why. We still don't know what caused that imbalance. The answer to this mystery may hold the key to understanding existence itself. If this journey through cosmic mystery intrigued you, subscribe now and join us as we explore the depths of space, science, and the secrets of being. And remember, sometimes, the biggest answers begin with the smallest differences.